In general, the density of a gas in grams per liter is a function of the pressure and of the molar mass. The general equation is density. In this case, we're dealing with CO2, so the density of CO2 is equal to the molar mass, or I'll just call it MW for molecular weight, in grams per mole, times the pressure in atmospheres, divided by R, the universal gas constant in liter atmospheres per mole Kelvin, times the temperature in kelvins. And as you could tell, moles will cancel with moles, kelvins will cancel with kelvins, atmospheres will cancel with atmosphere, and the units of the answer will be in grams per liter. Now, we are asked to compare the density of carbon dioxide at 0 degrees Celsius and 380 torr with its density at STP. So first of all, let's determine the density of CO2 under the initial conditions, condition 1, 0 degrees Celsius and 380 torr. In order to do that, we need the pressure in atmospheres. So P will be equal to 380 torr times 1 atmosphere for 760 torr, which is 0.500 half an atmosphere. And we need the temperature in kelvins, 0 degrees Celsius plus 273 gives us 273 Kelvin. So we can now plug in this information along with the fact that the molecular weight of CO2 is 44.0 grams per mole. So the density of CO2 and is equal to 44.0 grams per mole times 0.500 atmospheres divided by the universal gas constant, you remember that, 0.082 liter atmospheres per mole Kelvin, times the temperature, which is 273 kelvins. And when you evaluate this, the arithmetic answer is 0.98 grams of CO2 per liter. That's the density under these conditions, half an atmosphere pressure, 273 Kelvin. Now, the second part of the question says we should compare this value with the value at STP, standard temperature and pressure, which you recall is 1 atmosphere, 0 degrees Kelvin. So, at STP, we could, if we wish, plug in 44 grams per mole times 1 atmosphere divided by 0.082 liter atmospheres per mole Kelvin, and we put in the temperature, and we would find the new density. But I want to remind you that at STP, 1 mole of CO2 occupies 22.4 liters, the standard molar volume. So the density, given that information, will be equal to the molar mass divided by 22.4 liters. That's 44.0 grams over 22.4 liters, and that is 1.96 grams per liter. Now you can only use this shortcut at STP because only at STP does 1 mole of the gas occupy 22.4 liters. But since we have that here, we can now use it And we'll get the same result as if we plugged into the generalized density equation. Now, to compare these two, we will notice that when we go from half an atmosphere to 1 atmosphere, the density doubles, 0.98 to 1.96, and that, of course, is exactly what we would expect, since density is proportional to the atmospheric pressure. If we double the atmospheric pressure, keeping everything else the same, we should double the density.